Hello listeners, I'm Sindhusen AM, Assistant Professor, Department of Information Science and Engineering, Rajiv Institute of Technology, Hassan. So I'm going to teach DBMS laboratory with a mini project with the source code 21CS55. So let's get into the command prompt first. So we need to change the directory. So for that we have a command called cd space and we need to copy the path of MySQL server. So for that local disk C and then click on program files and then click on MySQL and click on MySQL SQL server 8.0 and click on bin. So after opening a bin, so we need to copy the path here. So just copy the path, close the window and just paste it at command prompt and click enter. So after this, so for accessing MySQL, so we have a command called MySQL space -u space root space -p, click enter. So here it asks for a password. So I have given password as password itself. So I am giving my password and click enter. So here we successfully access MySQL. So how I got to know I successfully access MySQL means, so here you can see your MySQL connection ID is 9. So therefore I successfully get into through the MySQL server. So after accessing, so we need to know which are all the databases it's already there. So for that we have a command called show databases. It should be plural form, that is show databases. So these four are the default databases. So this is how we'll access the database. Thank you. Hi listeners. So in this video, let us know about scheme and syllabus of DBMS System Laboratory with the mini project with the course code 21CSL55. So in the syllabus, the laboratory is divided into two parts, part A and part B. So part A contains 5 questions and or programs, and in a part B which contains mini project. So in this session, so let us know about what are all the queries which is included in the first laboratory program. So in the first program, they are saying that, so create a database name called library, and with that create tables called book, book authors, book publisher, book copies, book lending, and library program. So initially, so we need to create the publisher table. So why? Because in the book table, the publisher name is specified. So for that reference, so we need to create the table publisher first. So here publisher contains the attribute names called name, address, and phone. And here name is acting as a primary key and it should be a unique name. So let us create the tables. So initially we need to create the database in the name of library. So for that we have a query. So that is, for that we have a command. So create database library semicolon. So after that, to use that library database, we have a command called use followed by database name, that is use library. So now let us create the publisher table. So for that, so I have already written the commands. So that is create table publisher with attribute name, varchar of size. So here varchar is a data type and it is acting as a primary key, and phone it's an integer and address with a background. So to view it in a table form, we have a command called DESC followed by the table name. Here table name is publisher. So next we need to create book. So for that, I have already written the commands. So in the schema, so here you can observe that in the schema diagram you can observe that in the book the publisher name is referencing to the name of the publisher. So therefore the publisher name of book is acting as a foreign key and name of publisher is acting as a primary key. So let us create the table. So here also we can view it in a table form by using a command called DESC followed by the table name. So next table is book authors. So in the schema, in the book author, which contains book ID and author name. So book ID is referencing to the book ID from book and author name. So let us create the table. So again to do we have a command called DESC followed by the table name, that is book authors. So we need to create the next table, so that is library programming, and in the schema library programming. So here programmer ID is a foreign key and which is referencing to the book copies. So let us create the table. So to view it in a tabular form, DESC space library program. So we need to create the next table is book copies. So here two different primary keys of different entities. So let us create the table. So to view that, so DESC space book copies. So next we need to create a table called card. So for that, so why we create card means, so even though in the syllabus or in the schema they are not given card as a table name, here card is acting as a primary key. So therefore, so we need to create another table called card. So therefore, to create that, so create table card with a primary key. So to view that, DESC space card. After card, we need to create a book lending. So in the schema, book lending consists of these attributes. So here, book ID is referencing to the book ID of book, and program ID is referencing to the program ID of library program. So therefore, so these two become foreign key to the different primary keys of different entities. So let us create that. And again to do that, DESC insert the values into the different tables. So initially, so we need to insert a values into a publisher table. So for that, so I have already done the commands. So in that, in first tuple, so I am inserting into the publisher with the values author, book ID, and the location. So I am inserting 5 tuple at a time. So to view these inputted values in a table form, so for that we have a command called select star from the table name. So your table name is a publisher. So the second table is a book. So your book is consisting of book ID, title, public year, and publisher name. So here I have already written the commands and I am inserting 5 tuples at a time. So again, to view it in a table form, we have a command called select star from book. So next table. So next we are going to insert into the book authors. So in the schema, so book authors contains book ID and author name. So here book ID is acting as a foreign key to this primary key. So therefore, the values which is similar to book ID of book should be inserted. So for that, I have already written commands. So I am inserting the 5 tuples at a time. So again, to view, so select star from the table name. So that is book authors. So here you can observe that. So this book ID values and books of book ID values are similar. So the next table is the library programming. So here the library programming contains library ID, program ID, program name, and address. So here where program ID is a primary key. So let us insert 6 tuples at a time. So to view in table form, we have command select star from the table name, that is library program. So the next table is book copies. So here the book copies contains book ID, program ID, and number of copies. Here book ID is referencing to this book ID of book, and this program ID is referencing to the program ID of library program. So therefore, the value of book ID and program ID should be similar with respect to their primary keys values. So let us insert. So I am inserting 7 tuples at a time. So to view the table form, select star from so you observe that this book ID is similar to book of book ID, and this program ID is similar to, so library program is program ID. So the next table is card. So to insert into card, so I am inserting 5 tuples at a time. The card contains the only card ID and which is a primary key. So to view, select star from card. So the next table is book lending. So in the schema, book lending book ID is referenced to the book ID of book, and program ID is referencing to the program ID of library program. So the inputs to book ID and program ID should be similar with respect to their primary key values. So let us insert that. Table form, select start from book lending. So next, so we successfully inserted all the attribute values with respect to their entities. So next, so now let us solve the first query. So the first query is write a SQL query to retrieve details of all the book in the library database, that is book ID, title, name of publisher, author, and number of copies in each program. So here, so we need to retrieve. So here, so we need to retrieve these information. So that is book ID, title, name of publisher, author name, and number of books. So we need to write a select query. So let us write the query. So that is select. So there in the query they have given. So book ID. So book ID is from the table book. So this B is a alias name for that book table. And again, title is also from a book. So the alias name for book is B, and publisher name is also from book, so therefore alias name is B. And so author name. So there we have author name in this schema. So author is at, so author name is at book author. So I am giving A as alias name for book authors. So therefore it is A dot author name. And number of copies. So number of copies are from book copies. So I am giving alias name for book copies as C, and program ID is from program lending. So I am giving L as program lending, and it is from the book table and from the book authors table, book copies table, and the library table. So next I have to specify the condition. So here the condition is foreign key and the primary references. So between these four tables. So here, so book ID from book should be equivalent to book ID from author ID, because this is a foreign key and here it is a primary key. And so we have another foreign key and primary key references, that is book ID from book is equal to book ID from C. So why? Because book ID from book copies is a foreign key which is referencing to the book ID of the table book. And again we have another foreign key and primary key references, that is program ID from program lending is equal to the program ID of number of copies. So here this program ID is a foreign key references to this book lending program ID. So if we execute that, we'll get the same values which are present in these primary key and foreign key references, and we will fetch the tables as book ID, title, publisher name, author name, number of copies, program ID. So let us execute the query. Here you can see, so we have fetched the similar attributes or similar tables which has primary key and foreign key references. So next, the second one query is In the second query, so we have get the particulars of borrowers who have borrowed more than 3 books but from June to June Jan 2007 to June 2017. So here they are asking for the users or the borrowers who have bought 3 books in between the time gap Jan 2017 to June 2017. So then let us execute the query. So for that, so every borrowers have their separate card numbers. So therefore, we need to fetch that card number in order to get the number of borrowers who has bought 3 books during that period. So for that, so select card number from book lending. So why it is from book lending means, so just observe the schema here. So card number resides in the table called book lending. So again, the condition is where date out between, and this is a duration of date. So for that they have using a clause called date out. So date out between Jan 2017 to June 2017, and so we should group these card numbers during this duration by using a group by clause card number which is greater than 3. So to specify greater than 3, so we are using another clause called having count greater than 3. So here the asterisk means, so who are the borrowers, or fetch all borrowers name who has borrowed more than 3 books during this duration. So let us execute the query. So here you can see that the card number 501, he has bought or she has bought more than 3 books from the duration Jan 2017 to June 2017. Let's move on to the next query. So the third query is they are asking to delete book in book table and update the contents of other tables to reflect this data manipulation operation. So here we need to delete a book from a book table and update the contents of others table, and we need to replace or reflect those data for the data manipulation purpose. So let us see the query. So to delete the book, so here we have to delete from book, so where book ID is equal to 3. So let us execute the query. So to view whether we have deleted or not, so let us write a command select star from book. So here we can see that we have deleted a book ID which is equal to 3. So here you can observe that tuple 3, which means the row 3 which contains book ID 3 will be deleted, and this should be, and which means book ID 3 deleted tuple should be reflected in book authors also. So for that we need to see the book authors table. So here you can observe that, so we deleted book ID only from the book table, but here the tuple 3, that is the book ID 3, is got deleted from the other table called book authors. So it is why, because this book ID from book authors is referencing to the book ID of book. So let us move on to the next query. So that is, partition the book table based on year of publication, demonstrate it working with a simple query. So here they are asking partition or divide the books according to the year of publication. So let us see the query. So after partitioning that, so we need to create a view. So for that we have a query, create view v underscore publication. So here, so this v is an alias name for this view class. So create view v publication and select publications year from book. So let us execute the query. So if we separated the book according to their year of publication, so we need to write a command, that is select start from p publications, which means view publications. So here you can see that, so year of publication, so according to the year of publication they have separated. So let us see the next query. The next query is create a view of create a view of all books and its number of copies that are currently available in the library. So here we need to fetch the information that the books and the number of copies of that particulars. So let us see the query. So in the question they have asked create a view of all books. So therefore, so we need to create a view and the alias name for view is v. So therefore, so create view v books as, and we need to write a select query for fetching the information from book ID from table book and title from table book, number of copies from book copies, from which are the tables we need to fetch means from book table B and from book copies C and from library programmer L. So why? Because so in these tables, so in book and in book copies and in library program, so we'll get this program ID, title and number of copies, and then we need to write the condition, that is where, and we need to equalize the foreign key and the primary key references in these four or in between these four programs. So that is, so book ID from the book table is acting primary key to the book ID of the table book copies, and here this book ID of book copies is acting reference key, and also we have another primary and foreign key references, that is program ID from book copies is acting as a primary key, and where program ID from a library program is acting as a foreign key. So here this program ID is referencing to the program ID of library program. So let us execute this query. So to view, so whether we fetch all the number of book copies, so we have a command called select start from view books. So here you can observe that the book ID 1 with the title Basics of Excel has number of copies 10, and with the book ID 2 with the title Programming Mindset has the number of copies 20. So likewise, according to their book ID and title, their number of copies which is researched in the library are fetched. So this is all about the first program. Thank you.